This conference will now be recorded.
Hi, welcome back. Good morning, all. So, in our yesterday's session, we were discussing affinity and we discussed EFS storage also. We created one EFS file system and we created PVC, and we claimed through the pod. We were able to attach it to the pod, and later we discussed affinity. So, affinity is by default, Kubernetes scheduler will schedule your pods onto some node. We don't know what exactly which node is it. We don't have control usually, but to have some control, Kubernetes gives some option like node selector. Node selector is you can label the nodes and you can select which node your pod wants to run. So that is through the node selector. We discussed this, and the limitations in this approach were by mistake, if you give the wrong label, then the pod will go into the pending state. And if you want the anti pattern, like I don't want a node to run on particular node, sorry, I don't want a pod to run on particular node, then it is not possible through the node selector. It is only the positive approach. So for that we have an approach called node affinity. There are two things in it: required during scheduling, ignore during execution. Prefer during scheduling, ignore during execution. The first one is a hard rule. You can give the labels. Kubernetes will search that nodes and then schedule the pod. By mistake, if you give the wrong label, the pod will be on pending state. The second one is the soft rule. It will try to match your requirement. If it can't find, then it will schedule the pod into something else. That is this approach. You have both the hard rule and soft rule. And anti-pattern also is there. You can have not in operator. We already saw that example. And after that, we have to discuss now pod affinity. Similarly, you want your pod to run on a particular node. There is something called pod affinity as well. For example, already there are few pods running, pod 1, pod 2, pod 3. You want pod 4 to go into the node where pod 1 is running. So this is the pod affinity, right? Node affinity, you want your pod to run on a particular node. Pod affinity means if pod 1 is running already on node 1, you want pod 2 to go on to the node where pod 1 is running. Okay, so for this we have one use case. This can be a real-time use case as well. We can mix the node affinity, pod affinity in this use case. For example, this is a Kubernetes cluster. We have 3 nodes. You want to start a MySQL. The application is like there will be a front-end service running and it will need to connect to the database to fetch the data actually, but every time hitting the database, fetching the data, it will cause more latency. For that, we have something called Redis cache service, and application will hit the cache. If it finds the data, it can respond to the user. If it don't find the data in this, then it will hit the database. So this is the pattern. For this purpose, we want a database pod to run on node 1. We can label this with database node, and to hit the cache, if the cache service is in the same node, then the latency will be very less. Okay, it can get the results fast and the user experience will be good. So the requirement is you want an application pod and then cache pod onto the same node, but you should not run two application pod and one cache pod. You should not run like that. Every node, whatever nodes you have in Kubernetes, every node should have one application pod and one cache pod. This we can achieve through the pod affinity. This you know already. I want my MySQL pod to go on to the node 1. What I will do is I will use the node affinity. I will label this node 1 as DB tier, and then I'll schedule the pod here. And when it comes to this, we need to use pod affinity and pod anti affinity. Okay, so we will discuss this approach now. First, let us search Kubernetes pod affinity, or just go to this link. Oh, sorry, I pasted the wrong link. That was very good actually. Let me try to find it. Set IT next. Okay, this one. Okay, I just wrote that problem here, whatever he mentioned. Okay, now let us solve this. The first one, I want database, all the data related pods to go on node 1, because you can attach some storage like EBS or some hard disk to this node 1. This is node affinity. So let me get Kubernetes pod, the syntax. I'll create one pod affinity. Okay, so before that, you need to label this node 1 as a database node. Okay, now I will label this as database node. Kubernetes label node as dbtr. Okay, sorry, it's kubectl. Okay, it is already labeled yesterday. Okay, and then I need to create MySQL pod. Let's take this example. MySQL and MySQL. Okay, you need to provide some environment variables to MySQL. We saw that already, and that is MySQL root password. Otherwise, it will fail. Value can be admin123. Now you need to select the node selector. Okay, so what is the syntax? We have it here. This one, node selector. But to know exactly where it comes, let us see this node selector. Yeah, under containers, node selector. Just copy this. What is our label? Tier equal to DB. Okay, now I am telling Kubernetes scheduler to select the node which has the label DB tier. Okay, kubectl apply -f 0. Okay, I just gave it as 6. Okay, MySQL got created. Where it got created should be on 216. Okay, now it got created. We used node selector for this, but similarly you can use node affinity also. Okay, let us get the syntax of node affinity. This is the syntax. Remove this. Under spec affinity, node affinity required during scheduling, because we want it to be mandatory running on DB node. Otherwise, we don't want the pod to run. So I'm using required during. This is a hard rule. And what is the key? It is tier in. The value is DB. Okay. Now using node affinity, it goes to the DB node. Okay. Now let us see. Okay. It went on to the DB node. This is the node affinity. And now we need to see the pod affinity. This may be little confusing, but just observe. So first I want Redis to be there on the each node. Pod affinity is whenever, okay, let me paint it. So this is a node. What pod affinity is, you have pod 1 and pod 2. This is pod 1. Okay, I need to move it here. This is pod 1 already running. Now you want pod 2, which should go to the node where pod 1 is running, that is called pod 2. Okay, now I want, for example, you have another node also. There is another pod running, for example, pod 0. Now you want pod 2 to go on to the node where pod 1 is running. Okay, that is called pod affinity, because pod affinity means like. Pod 2 likes pod 1, so it wants to go there. Okay, now pod anti affinity means pod 2 hates pod 1. For example, pod 3. Let us take pod 3. Pod 3 hates pod 1. It don't want to go where pod 1 is running. So that is called pod anti affinity. Okay, any doubts till here? Just understand the affinity and anti affinity. Affinity means pod 2 wants to go where pod 1 is running, that is affinity. Anti affinity means pod 3 don't want to go where pod 1 is running, that is called anti affinity. Okay, pod affinity and pod anti affinity. Now I want Redis to run on node 2 and node 3, but I don't want it node 1. Okay, so now here we need to match node affinity, pod anti affinity, pod affinity, all the rules. Okay, so let us take Kubernetes deployment. I will implement, then you will understand slowly. Don't worry about deployment, we will discuss after this topic. Now I want this as a Redis. Okay, and app is Redis. Everywhere Redis. Okay, you got your containers, you got your image, everything. Now let us see how can we do this. Since we have two, I am giving two replicas. First thing, your Redis should not go to the node 1 where database is running. For that, we need to use node anti-affinity. Okay, let me take this node anti-affinity. But there is no node anti-affinity. You need to just give not in. Okay, so now in this case, while scheduling, the scheduler will see it should not go to the node 1 because there is a node anti-affinity that is done. Now I want, now the scheduler can run this on node 2 or node 3. Sometimes it can run both on the node 2, both replicas, because I am giving here two replicas are both on node 3. There can be multiple combination. We cannot predict. These two replicas can go to node 2 or node 3 or one in node 2 or one in node 3. There can be any combination, but I want it on two replicas, one in node 2 and one in node 3. So now I will apply something called pod anti-affinity. Now let you can see this carefully. Pod anti-affinity. Pod anti-affinity. App in Redis. Now let us decode this. I'm giving pod anti-affinity. I want this, for example, the first replica comes. I want this to run on a node where there is no Redis app already running. First, it will check this node 2. Is there Redis already running? No. Then it can schedule it onto the node 2. Then second replica will come. Then it will check the node 2. Already Redis is running. I gave pod anti-affinity. Then it will go to the node 3. That is pod anti-affinity. Any doubts? I will repeat once again. You understood this already.
Shiva,
Anti-affinity.
I couldn't. Yeah, this one. Can you tell me?
Yeah. What?
Yeah, this one. Spec affinity. Can you explain this one?
Node affinity or pod anti-affinity?
It's a node affinity.
Okay. The first thing, I don't want this Redis to go on to the database node because I want only database pods running here. So node affinity, and here you can see not in. Not in means it's a anti-pattern. So I'm giving scheduler, don't run this pod on a node where the label is DB. Okay, it is DB already, then it will not run here. It will run either here or here. That is node anti-affinity. And then I have two replicas. I want each one to run on a different node. First, I am giving pod anti-affinity. The first replica will come and it will check. The scheduler will check. User wants this pod, okay, running in a node where there is no Redis app. That is anti-affinity. Okay, it will check to the node 2 first and it will see, is there any app running with Redis? It is not running, then it will schedule here. And the second replica will come and it will check node 2. Again pod affinity. Already app Redis is running, then it will go to the another node. Okay, that is the anti-affinity. It's a simple trick here. Now let us schedule this. Okay, if you want, I can just comment this and then we can see. Now I just gave node anti-affinity with not in operator. Now the pod should not go to 216. It can go to any other nodes. kubectl get nodes. Okay. Now kubectl get pods -o wide. Now you see it is not running on 216, any two replicas. And the two replicas are running on different nodes. But we cannot guarantee this. Sometimes it can go to the both replicas can go to a single node. That we can't predict exactly. We will try to delete and then create again. Okay, now again it went on to different nodes. Let me try once again. Okay, again went on to different nodes. But we cannot guarantee this. We cannot take this chance. So what I'm doing is I'm doing pod affinity. Imagine this went on to the same node. Using pod affinity, I'm 100% sure, pod anti-affinity, I'm 100% sure it will not go to the same node. Okay, now let us delete. Create again. Now you can check, obviously it goes to different nodes. So this is done, Redis is done. Now I want Nginx. Okay, this is the first thing. I don't want it onto the database node. Let us do that. Same deployment. To Nginx. 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 First, I want node anti-affinity. First, I want node anti-affinity with not in operator. Then this will not go to that pod. And I want pod anti-affinity where app in Nginx. And then I want pod affinity as well. I want this Nginx pod to go where Redis is running. So here I will give Redis. Okay, understand this. First, I want pod not to go onto the node 1. And then later, I want a pod, the first replica pod, it should go to the node where Nginx is not running. Okay, first it will come to the node 2, Nginx is not running, then it will schedule here. And then second replica will come, it will check node 2, Nginx is already running, then it will go to the different node. And another thing is, it should go to, with affinity, it should go to and attach Redis like this using pod affinity. Okay, here in this approach, we use all patterns like node anti-affinity, pod anti-affinity, pod affinity. Okay, just understand this affinity and anti-affinity. Mostly we don't use in our practicals, generally in our offices. This is very rare requirement, special requirement, but you should understand this topic for interviews or anyone they will ask you this question. What is pod anti-affinity, node affinity, node anti-affinity required during scheduling? All these questions you may face. Okay, this requirement is very rare case. Now I will apply this. Now let us go and check. Nginx is also running and it came to different nodes. So with this technique, we got this solution using node affinity, node anti-affinity, and pod affinity, pod anti-affinity. Okay, any doubts still here? Maybe confusing little bit, but you need to practice it 1 or 2 times, then you will definitely understand this. Any questions? So if no questions, we can move on to another topic. Now we can discuss our core topics like namespaces and then services, replica sets, deployments. Okay, so there is one important topic called namespace. Okay, so this is your Kubernetes node. And you have 3 nodes. Okay, this is one Kubernetes cluster. You have 3 nodes. Many projects use this. If every project comes and schedule their own pods and there is no security, okay? Suppose project A, project B, everybody comes here and schedule their own pods in the nodes, then there is no security. For that purpose, there is something called namespace. For example, this is project A namespace. In this project A namespace, project B cannot schedule their pods. It is only isolated to the project A. Similarly, project B. Similarly, project C. Just like VPC concept in AWS. Okay, so namespace is a like isolation in Kubernetes. Project A will have its own namespace, project B will have its own namespace, project C will have its own namespace, and project A can schedule their pods, services, or deployments, anything in project A namespace only. Okay, so that is the namespace. Namespace is an isolation within the Kubernetes. It's a logical isolation. And another example is like in your Kubernetes cluster, you want to have multiple environments like dev and then test and then production. Production should not have access to dev should not have access to production. So in that, you can isolate using namespace. You can create one dev namespace, you can create another test namespace, you can create production namespace. Dev applications will be deployed in dev namespace, production applications will be deployed in production namespace. So that is the advantage of namespace. Okay, it's a isolation of resources, usually from one project to another project or one environment to another environment. So how to create a namespace? Let me delete this. Simple command kubectl create namespace dev. Okay, and then how to list down the namespace? Kubectl get namespace shortcut is ns. Okay, so till now we are working in a default namespace. And now I created new namespace dev. For every Kubernetes cluster, you will get default namespace automatically. And then kube system is for the Kubernetes administration purpose. These three. Okay. And if you see kubectl API resources, so these are all the Kubernetes resources. In that pod is also one of the resources, and it is like namespace level. If it is true namespace, then pods can be isolated within the namespace. And we saw config maps. It is namespace level. You can isolate config maps to a particular namespace. And then we saw persistent volumes. It is not a namespace, it is a cluster level. Okay, but persistent volume claims is a namespace level. You can isolate PVCs in the namespace. And we have deployments, replica sets. We will all see these topics now. And services. Mostly many resources are namespace level. Okay, you can isolate your Kubernetes resources in a namespace. Okay, now I created a namespace. But if I use the entire resources of all the nodes, then there is no use of test and production, right? When you create the namespace, you need to allocate some quota to it. For example, if your Kubernetes entire cluster has 100 CPU and then 200 GB RAM, then I need to allocate dev something like 20 CPU and 50 GB RAM, and test another 50 and then 50 GB RAM. And similarly, For production 100 and then 75 GB RAM. So like this, I need to allocate the resources. If you don't allocate like this, then there is a chance dev can completely utilize all the resources so that your production applications will not run. So always there is a thing called resource quota, Kubernetes resource quota. Okay, whenever you create namespace, your administrator will allocate some resource quota to that. Okay. So administrators will create the namespace for your project and then they will allocate some limit. Can see this. They will allocate CPU, memory, and then they can allocate number of config maps, number of secrets you can have, and the number of PVCs. All these things they can allocate through the resource quota. Now let us allocate something to our dev namespace. Let us take this example. Okay, we created a namespace already, dev namespace, and now I am allocating some quota. Okay, whenever you are giving like this, first you need to give here namespace. What is the namespace? Dev inside metadata section. Now I am allocating a quota to my dev namespace and CPU. CPU can be 1 for my entire dev namespace. For dev namespace, I am allocating CPU to 1. This is requests, and then CPU to 2. This is limits. Okay, this is total number of pods running. If I have 5 pods running, 5 pod CPU request should not be more than 1, and 5 pod CPU limits should not be more than 2. Similarly, memory. Now let us apply this and then check. Okay, kubectl apply -f01 quota. Okay, now kubectl get resource quota. This is for the default namespace. If you want to select a particular namespace, you need to give -n dev. Okay, now this is the one we created just now. The total CPU request is 1 and the current usage is 0. This is usage per total. Okay, now let us schedule one pod and then see. Okay, limits is 800 out of 2 and then CPU is 800. Okay, CPU is 800 out of 2. Memory is also 800 MB out of 2 GB, and then requests memory is 600 out of 1 GB. CPU is 400 out of 1. Okay, now this is good. What I will do is, for now I will comment this and then let us check whether you are able to create the pod or not. Okay, pod is created in default namespace actually. You see here, pod is created in default namespace. If you want to go in a particular namespace, you need to give here namespace dev. Now you see here, you are getting one error. Must specify this limits, because you are restricting the namespace with some limits. If you are not mentioning this, then how Kubernetes will calculate the limits? So in that case, it will give you an error. So you must specify your limits in every pod so that Kubernetes will calculate it. Okay, now let us check. Now the usage is this one. You have your pod running and the usage is as per your given. And let us create another pod. Now this time the resources will be more. Okay, now I am giving 1 GB limit. The limit is how much empty? 1 GB. Okay, 1 GB RAM. Okay, 1 GB is free, and then 0.8 CPU. Okay, 0.8 CPU is free, and then request 700 MB. Here it is not free. Here only 400 MB is free, and then 400 CPU micro. Here it is fine. So only thing it is overutilizing is memory. Okay, here the request memory is only 400 is free, but I am giving 700. Now I should get the error. Okay, it got again same mistake I did. I need to give here namespace dev. Okay, in real time what administrators will do is they will delete the default namespace. See, now you got the error, exceeded quota. Okay, so usually we will have some 10 CPU, right? 10 CPU, 10 GB RAM, 20 CPU, and 20 GB RAM. Let us see, at least we have 10 CPU or not. Ours is like a simple cluster. Okay, now it is running. Let us check the resource quota. Yeah, so we have. So this is how you apply quota to your namespaces. Oh, okay, but mostly if the application team forgets to give these resources, Kubernetes is giving error. But we already discussed something called limit range. Using this limit range, you can give the default. The application team forgets to give those resources, you can configure the default through the limit range, so it will not give you that error. Okay, that is about the resource quota. And let us give some more things called config map secrets also. Okay, there is an example here. Okay, this is like CPU and memory, and this one you can see you can also configure config maps, persistent volumes, secret services like that, number of ports. So in this dev namespace, you can only create 10 config maps, 4 PVCs, and 4 ports, 20 replication controllers. Okay, this is the limit. So these operations are done by administrators in real time. So whenever they get a request for project creation, they will create the namespace and they will allocate the limits. They will create the users and they will hand over the credentials to the application team. Okay, now you can see the resource code. Okay, this is the namespace and the resource quota. Now we need to discuss a topic called services, Kubernetes services. We know the pods already. We practiced very well, mostly all the topics in the pod. Okay, suppose this is the cluster and inside you have nodes, some 3 nodes. Your pods are running. These pods are internal IP addresses to the Kubernetes cluster. You cannot access this pod outside of the Kubernetes cluster. Okay, that is one limitation. And other limitation is I have my front end pod and I have my user microservice. Okay, forget about microservice first. And if there is a front end application running and there is a user multiple VMs to handle the load, like this is VM1 and this is VM2 and this is VM3 and this is VM4. Okay, so I have my user application running in all the VMs. This is front end. This is the usual architecture of the applications, right? Now, how front end can connect all these user applications? Okay, so I can earlier if it is only one, I can hardcode the IP address in the reverse proxy of this front end. Like whenever you get a request with slash API slash API slash user, then I can configure it. Then I can configure it to connect with VM2, hard coding the IP address. But if it is multiple VMs, what should I do? Usually I need to keep another load balancer in front of this VMs, and your front end will connect the load balancer. Your load balancer balance the load between your VMs. That is the usual approach, like normal applications. Okay, if the load is not sufficient, you will create another VM and then you will configure the load balancer again with this VM5. Okay, when the load is less, you will delete VM5, you will delete VM4. Again, you need to configure the load balancer to accommodate that change. So this is the usual approach, right? But in case of microservices, the IP addresses are not permanent. Those are like ephemeral. Whenever you create the pod, it will give you one IP address. Whenever you delete it, the next IP address may be different. So it's completely unpredictable ephemeral environment, the pod. Now I have hundreds of microservices. I cannot create 100 load balancers. I cannot get the IP. I cannot configure it manually. Everything, these things I cannot do it manually. Okay. So this is the biggest problem in microservices world. Then for that purpose, what the industry did was something called service mesh. Okay, this is microservice 1, this is microservice 2, this is microservice 3, this is microservice 4. Like we have like user, cart, catalog, shipping. We have these microservices, right? Now usually if catalog wants to connect it to user, and catalog wants to connect to shipping, catalog wants to connect to cart, and shipping wants to connect to cart. So like this, there will be multiple communications between the microservices, and cart wants to connect to user. This is the biggest problem. Everyone wants to connect with another application, and these IP addresses are keeps on changing. So in that case, I cannot have multiple load balancers. That will increase the cost, and the configuration problem also it is very high if you go that approach. Then, so what happened was there is something called service mesh or service discovery. Okay, what happens is whenever the user application starts, it will register its IP address with service discovery. Similarly, this one, whenever cart application starts, then it will register its IP address with service mesh. Say whenever catalog application starts, it will register with service discovery. It can be any number of replicas. Okay, it can be also any number of replicas. And same shipping also registers its IP address. When catalog wants to connect with cart, what catalog will does is catalog will ask for service discovery. What is the IP address of cart? Then service discovery will send this catalog. This is the IP address cart register with me. Then catalog one will directly connect with cart with that IP address. Okay, this is called as service mesh and service discovery. When there are a lot of microservices, when lot of applications running, if their IP address is not is ephemeral or keeps on changing, then you will install a component called service mesh or service discovery. And whenever this application starts, this go and register itself with the service mesh. Now, if user wants to connect to catalog, then user will first call service mesh. What is the IP address of catalog? Then service mesh will send the response. Then it can call it easily. Okay. Service mesh is a kind of mediator in between the microservices. Okay. In Kubernetes environment, the same service mesh or service discovery is implemented through a simple component called services. Okay, actually service mesh is very complex. Kubernetes made it very simple through its internal implementation called Kubernetes services. Okay, Now, if you want, every pod will have its own service. Service can be act as a load balancer also here, right? So earlier we have multiple pods. Okay, this service is like a, you can just think like it's a load balancer. You can attach this. This is a simple change between service mesh and then Kubernetes implementation. You attach this to a service called user service. It will give you one name. Okay, and then catalog will have its own service. All these IP address, like there are 3 pods, right? All these 3 pod IP address will register with user service. This is called catalog service. Okay, these 2 catalog will associate with this catalog service. Similarly, shipping, similarly, cart. Okay, so every service will give you one name. That name is permanent, it will not be changed. Now catalog wants to connect to user, then catalog will send a request to the catalog service. Okay, this is like a load balancer. Then this service can send the request to any of the pod balancing the load. It will send the response. Okay, so what is the problem solved here? If catalog wants to directly connect to the user, it needs to know its IP address, but it has 3 pods, 3 replicas. How can it call 3 IP address randomly? And those IP address will keeps on changing. Whenever you restart the pod, whenever you redeploy the pod, the IP address will change. So for that purpose, every pod will have one service attached to it. If it is 1 replica or 2 replica or 3 replica, every pod will have one service attached to it. Then other pods can call this pod through its service name. Okay, now I will call like user service slash something, whatever I want, get user with ID 120. Now the request will go to the user service. User service will call any of this pod and it will send the response. Okay, if someone asks what is Kubernetes service is like a service mesh kind of implementation which balance the load between the pods and it can solve the pod to pod communication problems. Pods will attach to the service and other pods can call with the service name. Okay, any doubts still here? Is it clear? Ravi, Senthil, Gopi?
Yes, sure. It's clear.
Okay, then tomorrow we will create the services to our pods. Okay, and then we can discuss this concept. There are multiple types of services: cluster IP, node port, load balancer, all those things we can discuss tomorrow. Okay, that's all for today. See you in tomorrow's session. Have a nice day.